Now let's debug this code. In the ITM data console, don't start the trace. Okay, so don't do anything here. You can just close this. So first let's check using our debugger. Okay. Let's keep the breakpoint in task 2, task 3, and task 4. Anyway, task 1 is executed by us, so need not to keep a breakpoint here. Now let's see the execution control comes to task 2 or task 3. So if it is coming, then we can say that the context switching was successful. Okay, but before that we have to make sure that there is no crash or there is no faults. Okay, now let's just run this code. So here it is. There is a hard fault. Okay, so something is wrong with the code. Let's go to the fault analyzer, and we don't have sufficient information. You can see that everywhere it is mentioned not applicable, something serious happened, and the fault is related to stacking error, precise data access violation. So something related to the stacking error. And so since we don't get any information here, what we can do is we can debug step by step. Okay, now let's reset the board, and let's first just execute this function. Let's see whether it executes fine or not. I'm going to step over. Yes, that's fine. Step over. This is also fine. Okay, all these are fine. No problem here. Sysdig executed successfully. Switch SP to PSP. Yes, that's correct. So that means that the problem may be in the Sysdig handler. Okay, so let's keep a breakpoint in Sysdig handler. Let's run. So we will get a Sysdig exception. Yes, we got the Sysdig exception. That's correct. Now let's execute these instructions. No problem here. No problem here. Everything is fine. Right. So here it is. So up to here, there is no problem at all. And when I execute this one, and now let me try to leave the Sysdig handler. And now let's do single step. And here it is. There is a problem. Okay, it is not getting executed. It is not exiting that Sysdig handler, right? So it is showing somewhere else. So now let's again hit step into, and you can see that it resulted in a fault. So we know that up to here there is no problem in the Sysdig handler. Let's reset the board once again, and let's remove all the breakpoints. Let me remove all the breakpoints, and let me keep only one breakpoint in the Sysdig handler at this position, because after this position we encountered hard fault, so we have to investigate that. Right, hit run. So after this line, Sysdig will make an exit. We did one mistake here. So the mistake is, let me explain you. Let's go to the registers. Take a look into the value of LR. This is the value of LR, which is wrong, isn't it? So LR must contain exec return. That is helpful during exception exit. So but we corrupted the value of LR. That's because of these intermediate function calls. So here we did a mistake. So before you use BL instruction, you have to save the content of LR. So that's why here you have to add one more instruction, ASM volatile push LR. Okay, because here the LR value is going to change, and here it is again going to change. Here it is again going to change. Here you have to pop it back. Please note that this function has to be a naked function, because we don't want compiler to insert any prologue or epilogue sequences. I will add this attribute to this. Since we made this function as a naked function, epilogue sequences will not be added by the compiler. That's the reason we have to manually write the instruction to make exception exit. When exception exit happens, when the exec return value is copied into PC. We have to do that now manually, because compiler will not generate an instruction because it's a naked function. Let's do BXLR. So the magic number, that is exec return, is copied into PC, and exit sequences will trigger. That's it. After that, we have to do one more check here in the init task stack. Here, take a look into this line. Let me keep a breakpoint there. Here we are saving the address of task handler. Remember that the address of the task handler must be odd because the least significant bit represents the T bit. You have to make sure that you store a odd address. We have to verify this code. First, let me recompile and reload the application. Let me hit run, and yes, it is stopped here. Go to the expression window and let me examine this array. Drag and drop here. Let's examine the first element. Yes, it is odd. Then no problem. So we did correctly. Suppose if you check the address of task1 handler, just type that, you get the address. It is 23C. You must store 23D. 23D, that's correct. That looks like our code is fine. Let's test. What I would do now is I'm going to keep some breakpoints in task 2, task 3, and in task 4. Let me reset and run. We launched task 1, and from task 1 we came to task 2. Let's run. Now let me remove this. Run. Yes, we came to task 3. And let me remove this. Hit run. We came to task 4. That's correct. Let me remove task 4. Put a breakpoint in task 1 and let's run. Yes, it's happening. Context switch is indeed happening. What I would do now is I will remove all the breakpoints and go to show view SWV ITM data console. Here let's trace. Let me reset, run. Yes, it's happening. So here you can see that the tasks are indeed getting scheduled. You can see that first task 1 was running, then it is preempted by task 2, and after that task 3 and task 4, and after that task 1. In a round robin fashion, the scheduler is doing context switching between multiple tasks. But our ITM 5.4, that is not guarded. That's actually a shared resource between multiple tasks. That is not guarded in this case. That's the reason you see all these corrupted messages or distorted messages. In the next lecture, let's use the multiple task to toggle multiple LEDs of the board. On the discovery board, we have 4 user LEDs. We have 4 tasks. Let's write a program so that each task controls one LED. Each task should toggle a LED with some duration. If we can implement that program, then we can observe all the LEDs toggling at the same time. So we'll do that in the next lecture. Before that, please go through this application. The source code is available in our repositories. Try to go through that, and if you have any doubt, feel free to ask in the Q&A section. I'll see you in the next lecture.